This video is going to be part 2 on lists and tuples, and this is primarily going to be about picking multiple elements. So the main problem we have to cover is how to pick multiple elements from a list. Let's say we have a list with the numbers 1 to 4, and we want to get the second and the third element. How could we do that? Right now we can only pick a single element. Fortunately, Python can do this with something that is very similar compared to indexing, and that is slicing. How this works is you are still going to need square brackets, like with indexing. But now, instead of adding one number, you are adding two numbers separated by a colon. The first number is the start, and the second number is the end value. For example, it could look something like this. For example, in here, we have the indexes from 0 to 3. 1 right now is going to refer to this 2 here, and 2 is going to refer to the index number 2, which right now is going to be a 3. This is how we are picking the start and the end value. However, there's going to be a really important concept you have to understand. And that is, Python only goes up to the end, but it does not include it. Which means in this case, we would only get one number. We would be starting on this 2 here. That is our start value. However, we are only going up to index number 2, we are not including it. So in practice, our list indexing ends here, right before our end index. As a consequence, this operation here is only going to return this 2 and nothing else. That is going to be a fairly common issue, but you will get used to it. Let's practice this one. Once again, here I have a completely empty Python file, and I want to create a test list. And that is the list we have just seen. This one has the values 1, 2, 3, and 4. And just to demonstrate what I've just talked about, I want to print my test list. And in here, I want the values from 1, 2. If I now run this, I am getting another list with 2. That means that list slicing always returns a list, even if there's only a single value inside. For example, what we could even do is go from index 1 to index 1, which would get us, if I run this, an empty list. And this is something you always have to keep in mind. If you want, in this case, for example, the second and the third element, you have to go to the index after that. In this case, this is going to be 1, 2, 3. If I run this now, we are getting the numbers 2 and 3. And that for start is all you have to know about slicing. Although you can do quite a bit more, but let's talk about this inside of my slides. Besides the start and the end value, you can also add a third number for the direction. By default, this one is going to be 0, meaning we are always moving +1 in the positive direction. It might look something like this. We again have the same list, and we have our indexes 0, 1, 2, and 3. And this one here at the end means that we are moving in the positive direction in a step size of 1. Which right now would get us the next element, but we could have a larger or smaller value. You could also have negative values to go into the other direction. Here we are back in the code, and I want to add a few more values to this list so it's a bit easier to visualize what's happening. Now we have the values from 1 to 10. Although, if I run this one here, it is going to give us the same result. But now, let's say I want to have the values from 0 to 8. If I run this, we are getting the first 8 values. Although now what I can do, I can add another set of colons, and then, for example, add a 2 in here. And now if I run this, I am only getting every second value. So we are starting at the index number 0, and we are only ever picking every second value, which is the 3, the 5, and then the 7. And since our last index is going to be here, we are not including this 9 anymore. And then we are getting the values 1, 3, 5, and 7, the values down here. And this step size can also be negative. For example, you could in here add a -1, although right now this wouldn't do very much. So the issue here is we are starting at this value as our starting point, and our end value is 8, which I believe is this value here. And since we are now moving in this direction, there simply isn't any value. So this entire operation doesn't give us anything. However, what we can do is flip those two around. So our start value is 8 and our end value is 0. If I now run all of this, we get all of these values reversed. And negative values you can add actually everywhere in here. So for example, you could have the start value of -1 and the end value, let's say, at 4. This is going to work just like normal indexing. This would mean you are starting here all the way at the end. That is the -1. And then we're going to the fourth element, which is going to be 0, 1, 2, 3, and 4. This one here is index number 4. So we are expecting to get the numbers from 10 to 6. Let's see if that's the case. And it is. We get numbers from 10 to 6. And that is basically all you have to understand about the basics here. Although there's one more thing that you can do. And that is you can also leave values entirely empty when using slicing. This might look something like this. This does look a bit strange, but it does work. What it means is, let me talk through it. Every number in the slicing operation has a default value. So we have a start, an end, and a step value. For start, the default value is always the very first item inside of the list. In the example here, it would be a 1. The end value, by default, is always going to be the last item inside of the list. In this case here, that would be a 4. And for the step size, the default value is a 1, which means we are always moving +1 in the positive direction by default. This one should make sense. It's quite straightforward. And let's play around with all of that. Let's see how far we get. So here we are back in the code, and let me actually add all of this inside of a variable. Let's call it negative slicing. I should probably add more variables so it's easier to follow in the notes. But let's start working on leaving values empty. This I want to save in a variable. Let me call it default slicing. In here, as always, I need my test list. And in here, I want to go from my start to the end of the list. And I only want to get every second value. Now, the start is going to be easy because this one is always going to be 1. But you could also leave it completely empty. It would have the same result. And here, we could also leave empty. That would get us the very last item inside of a list, 10 right now. And this is actually really useful because by default, we don't know what the last index is going to be. Finally, I want to have every second element. This would be a 2 in here. And now, let me print the default slicing variable. Let's run this. And we're only getting every second value. We could also add every third value in here. And there we go. If you left all 3 of them empty and run this again, you would get all of the numbers. So this is looking a bit strange, but it certainly is working. And this system can be incredibly useful. As a consequence, let's do an exercise. And what I want you guys to do is this exercise here. I want you guys to start from 8 and go to 2 and only pick every second element. And when I say 8 and 2, I mean actual number, not indexes. So you want to start at this 8 here and then go to this 2 here at the end. These are the values you are going to cover, except only every second element. Meaning this 7 shouldn't be in here, this 5 shouldn't be in here, and so on. So pause the video now and try to figure this one out. Let me save all of this inside of a variable, and as always, we need the test list. In here, we need square brackets for slicing, and now we need a start, an end, and a step size. Since we do have to go negative, remember we are starting from 8 and we are going to 2, this has to be a negative number. Let's say -1 now, just to have a start value. While I do this, let me show the solution. Right now, what we are going to get is the entire list in reverse. Although in my case, I don't want to start at 10, I want to start at 8. Meaning we have to figure out how we can get this 8 here. That would be our start value. And one mistake you could be making in here is simply add an 8, because this would not work. Right now, we are starting at 9. The problem here is, remember, when we're using indexing, we are starting at 0, meaning this is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Meaning if we are adding the index 8, we are adding on the 9 here, which isn't helpful. Instead, what we could do is add a 7 in here, and now if I run this again, we are starting at 8. Alternatively, what you could also do is add a -3 in here. If I run this one, we are also starting at 8. And I guess, remember, we could also go negatively, so this 9 would be -1, then we have -2 and -3, that would be our 7. Both would be fine, it's really up to you what you prefer. I guess the 7 here is a bit more expressive, but, well, it's basically subjective. But now we have to find the end value. And in here, you might be very tempted to pick 1 for the index. Let me actually do that. If I add a 1 in here, run this again, we are ending on 3 as our final element. The reason is that Python always only goes up to the final element, but it doesn't include it. As a consequence, 3 is going to be our final element. The way around that one is this should be a 0. Now our final element is this 0, so we're going up to that element, but we're not including it. So 2 is our final number. The final thing we need is we only want to pick every second element. This is quite easy. All we need is a -2. If I now run all of this again, we get 8, 6, 4, and 2. And with that, we are done. This is basically all you need for slicing. And this would also work for a tuple. I guess, let me demonstrate this one really quick. Let's call it tuple slicing. And in here we have a test tuple. And this one would just have the values 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And in here, I could, for example, print test tuple with the values 0, 5, and let's say 3. This should be a colon. And let me comment out the exercise here. And there we go. We get 1 and 4. Once again, a list and a tuple are incredibly similar. The only difference is that a list can be modified, whereas a tuple cannot.